One of the first questions you may ask yourself learning chemistry is, what is a mole? First off, that is a great question to ask, and second, it's also super important to know the answer. Well, that's what this video is all about, to answer this question with the easiest possible explanation. So, what is a mole? A mole is a unit for measurement for a given substance. Now, substances can be seen all around us, but in chemistry we care more about substances at the chemical and molecular level. These substances can include both compounds and molecules such as NaCl, O2, and C6H12O6, which is table salt, oxygen that we breathe, and sugar respectively. Just know that substances can also be represented by single elements as well, such as individual Na or Cl if we break up table salt. Now, since a mole just represents a unit for measurement, there has to be a number that we can actually visualize this concept, and that number is 1. 1 mole of something has to be equivalent to something else, which we will know the answer to in about a minute or so. But first I want to try and connect the idea of 1 mole to things that we already know and understand. We already have words that are used to group together a larger number of something for simplicity purposes. For example, if you had 1 dozen eggs, you would know that that equals 12 eggs. And in fact, a dozen of anything will equal 12 of that same thing, unless we are talking about a baker's dozen, which equates to 13 of that thing. And as another example, 1 pair of shoes would equal 2 shoes. And whenever you have 2 of the same thing, it would always be called a pair. A pair of socks is 2 socks, and a pair of mittens is 2 mittens. So with this in mind, 1 dozen of something and 1 pair of something equal to the same total amount of that something, which is 12 and 2 respectively. So what does 1 mole of something represent? For this, try to envision 1 circle, which we will say is a particle. Now take that 1 circle and add many, many, many circles to it. So now you have trillions and trillions of circles all floating around. This amount of circles you envisioned is actually still smaller than how many particles 1 mole equates to. 1 mole of something actually equals to 6.022 times 10 to the 23rd particles. And that's a lot. But that number will never change if you have 1 mole of something. So who in their right mind would be able to come up with this idea that 1 mole of anything equals to 6.022 times 10 to the 23rd particles? It actually was Emilio Avogadro. And no, it is not avocado. And just like the majority of scientists, he named this finding after himself. So he coined the conversion that 1 mole of something equals to 6.022 times 10 to the 23rd particles to be Avogadro's number, or Avogadro's constant. There is a variable that goes along with Avogadro's number, which is n sub a. So all of these 3 things are equivalent with each other. Now, you may be asking, what is a particle? A particle can be seen as 2 representations, depending on what type of substance you have. These 2 things are atoms and molecules. You would say that you have 6.022 times 10 to the 23rd atoms of something if it was describing just an element, like elemental sodium or chlorine. But you may say that you have 6.022 times 10 to the 23rd molecules of something if it was describing either a compound or an elemental molecule. So you had 1 mole of H2O or KCl, which are both compounds, you would have 6.022 times 10 to the 23rd molecules of H2O or KCl. And if you had 1 mole of O2, which is an elemental molecule, you may also have 6.022 times 10 to the 23rd molecules of O2. So now let's get some other examples, just to get comfortable with the conversion of 1 mole of something equals 6.022 times 10 to the 23rd particles of that something. Well, 1 mole of nitrogen would equal 6.022 times 10 to the 23rd atoms of nitrogen, since it's just an element that would look like this. And 1 mole of lithium would equal 6.022 times 10 to the 23rd atoms of lithium, since it's just an element that would also look something like this. Now, if we had 1 mole of CH4, which is that stinky compound methane, you would have 6.022 times 10 to the 23rd molecules of CH4. Now notice the difference in the change of the word from atoms to molecules here, because instead of 1 single circle, or atom that's being represented like in nitrogen or lithium, CH4 has 1 carbon atom binding with 4 hydrogen atoms, and this binding of the atoms turns it into 1 single molecule. Now, let's try to perform actual conversions with this knowledge. So let's take the conversion 1 mole of lithium equals 6.022 times 10 to the 23rd atoms of lithium. Now, in order to use this knowledge to convert from one unit to another, you should know that since these two things are equal to each other, we can write them as two separate ratios. Ratios are written just as fractions, in which you would have one unit being either the numerator or the denominator, and whichever one that unit is on, the other unit has to be on the opposite side. So, if we can use this idea to write two separate conversions, we can say that there's 1 mole of lithium per 6.022 times 10 to the 23rd atoms of lithium, and since they are equal to each other, we can flip the ratio and say that 6.022 times 10 to the 23rd atoms of lithium per every 1 mole of lithium. Okay, so conversion time. Let's say that we have 9.72 moles of lithium and we want to know how many atoms of lithium there are. Well, knowing that 1 mole of lithium is equal to 6.022 times 10 to the 23rd atoms of lithium, do you think that 9.72 moles of lithium would equate to a larger or smaller amount of atoms than Avogadro's number? Well, since we have more than 1 mole, we can safely assume that we have a larger number of atoms than Avogadro's number. Now, let's find the actual number. Whenever you are converting from one unit to another, in this case, it's from moles to atoms, you always will multiply by some ratio. We have already set up the two possible ratios from before, so now it just comes down to knowing which one to use. From algebra rules, you will always use the ratio in which the unit you want to cancel out goes on the opposite side of what is given. In this case, we essentially want to get rid of the unit moles of lithium and replace it with atoms of lithium. So, with this information, 1 mole of lithium should go in the denominator to cancel out the given unit of moles of lithium, which leaves 6.022 times 10 to the 23rd atoms of lithium to go in the numerator of the ratio. When this happens, the unit moles of lithium will cancel and you're left with the unit atoms of lithium. Now we will just multiply across and get the answer of 5.83 times 10 to the 24th atoms of lithium. This goes with our assumption from before that our answer had to be larger than Avogadro's number, since we started out with a larger amount of just 1 mole. Now let's change the conversion a little and say that we have 1 mole of CH4. This would now be equal to 6.022 times 10 to the 23rd molecules of CH4. Now, how it is still Avogadro's number, but just a different unit because CH4 is a compound and not an element. Now let's say that we have 6.72 times 10 to the 24 molecules of CH4, and we want to find out how many moles of CH4 there are. We will use the same reasoning as before, in which, since we are converting, we need to multiply by a ratio and start with putting the unit we do not want on the opposite side. In this case, it will be 6.022 times 10 to the 23rd molecules of CH4 going in the denominator to cancel out the unit molecules of CH4, which leaves 1 mole of CH4 as the numerator. When this happens, we have successfully canceled out the unit that we don't want, which leaves us with the unit that we do want, which is moles of CH4. Now in this case, we take 6.72 times 10 to the 24th and divide it by 6.022 times 10 to the 23rd to get our answer of 11.2 moles. Now it's your turn. Here are two problems that you can perform on your own to make sure that you really understand this concept. Write the answers in the comments to see if you got it correct. And after you've done that, you can safely say that you understand this topic completely. So, next time someone asks you, what is a mole? You can tell them now everything that you have learned. And that concludes this lesson. I hope you guys all enjoyed it. And if you would like to support us, subscribe to the channel. If you want more practice problems, we have supplied you with hundreds of OpenStax answers like this one that you can look through at your leisure. And if you want to personally get tutored by either myself or my brother Andrew, check out our website at glasertutoring.com. Have a great day and happy studying.